Now, to solve exponential equations where you have different bases, then you're going to have to use logs. Well, there's a couple ways, but I like to just go ahead and apply logs. Now, in most cases, you can apply either the common log or the natural log. But let me show you how we can attack this problem. 7 to the 2n equals 325. So obviously we want to solve for the n. Well, there's a log property that says if two things are equal, like I have here, then their logs will be equal. And I can use any log I want, so I'm going to use common log. So if these two are equal, then the log of the left-hand side must equal the log of the right-hand side. And again, I could have used natural log. Now, what that allows me to do, if you'll remember one of the log properties that said if you have the log of an argument to a power, you can write that as the power times the log of that argument. Okay, so now I have 2 times n times the log of 7 equals the log of 325. Now, you might not need this next step, but I'm going to go ahead and move the n over here to show you that if you want to isolate the n, to get the n by itself, this is just 2 log of 7 times n. So to isolate the n, just divide both sides by 2 log of 7, and then that will give me n equals the log of 325 divided by 2 log 7. When you put it in the calculator, you might want to make sure you put parentheses around this so that it calculates this product before it divides it into this log. Okay, here's another example. Here I have 10 times 1.005 to the 12t equals 500. So what I want to do first is I want to get rid of the 10. So I'm just going to divide both sides by 10 here. And then if I divide both sides by 10, then of course over here it'll cancel, and then over here I'll just get 50. So now I have something similar to what I had over here. So over here I have two things that are equal, and my variable or my unknown is an exponent. So I'm going to use logs. So I'm going to take the log of both sides. Now here I'm going to take the natural log. Again, I could have taken the common log. I'm doing one of each so you can see that it doesn't really matter. So I'm going to take the natural log of both sides this time. So if I take the natural log of the left, then I got to take the natural log of the right. And when you take the natural log of 1.005 to the 12t power, you can use that log property and write that as 12t times the natural log of 1.005. Well, and again, I'm going to move the t over here so you can see that to isolate the t, what I've got to do is divide both sides by this product, 12 times the natural log of 1.005. So then I take natural log of 50 and divide it by 12 times the natural log of 1.05. And again, make sure you put this in parentheses on the calculator. And you'll get 65.363 to 3 decimal places. Now, this next one is actually a harder one because unlike the first two I only had an unknown exponent on one side. Here I have an unknown exponent on both sides. So here, if I'm still going to take the log of both sides. So I'm going to take the log of this and the log of this. Now, the log of this, the log of 3 to the 2x minus 1, remember I can write my exponent down here and make sure you put it in parentheses. So you have the 2x minus 1 times natural log of 3. And then I'm going to take the natural log of this so that I can write that as 3x plus 2 times the natural log of 7. Okay, now, so what I need to do here is I need to distribute these logs through this. So I need to distribute the natural log of 3 through these terms and the natural log of 7 through these terms. So if I multiply 2x times natural log of 3, then I'm just going to get 2x times natural log of 3. And if I multiply negative 1 times natural log of 3, I'll just get minus natural log of 3. Now over here, if I take 3x times natural log of 7, I'm going to get 3x times natural log of 7. And if I take 2 times natural log of 7, I'm just going to get 2 times natural log of 7. Now, what I want you to see in this step is that I have two terms that have an x in them. That term and this term. So if I'm going to solve for x, I need to get these two terms on the same side of the equal sign. So I need this 2x natural log of 3 and the 3x natural log of 7 on the same side. So what I'll do is I'll take this term, 3x natural log of 7, and I'll move it across the equal sign. Now you remember what that does when you move it across the equal sign. So the 3x natural log of 7, when I move it to the other side of the equals, becomes minus. So now I have 2x natural log of 3 minus 3x natural log of 7. Now you might be wondering what happened to the minus natural log of 3. Well, since it didn't have an x in it, I booted it to the other side. So if I move the minus natural log of 3 from the left to the right, it's going to be over here with this 2 natural log of 7, but when I move it across the equal sign, it's going to be positive natural log of 3. So to make a long story short, I just moved the 3x natural log of 7 to the left, and I moved the minus natural log of 3 to the right, and of course I had to change their signs. Now, here's how that helps. Now I have two terms that both have an x in them, so all I have to do is factor the x out of these two terms, and I get x equals this expression, 2 natural log of 3 minus 3 natural log of 7. Now all that is a number. It's some number. You can plug it in your calculator and figure out what it is. But anytime you have x times a number and you want to isolate x, then just divide both sides by that number. So if I want to isolate x, I just take this and divide it by this, and then that'll give me x. Now again, when you do that calculation, make sure you put the numerator in parentheses and the denominator in the parentheses on your calculator so it will do the right order of operations. And the answer I got was negative 1.371. Now, you'll notice here on these problems I used log one time and I used natural log the next two times. But actually it doesn't really matter unless your base, if your base is e, it does speed things along if you use natural log, and if your base is 10, it speeds things along if you use common log. And the reason is, if you take a look at this, e to the 5x minus 2 equals 25. Well, the natural log of e to some power is just going to be the power because the natural log and the base e have the same base. So when you do the natural log of e to a power, they just basically kind of cancel each other out and you just get the power. So when I take the natural log of that, I just get 5x minus 2, and that equals natural log of 25. And then you know how to solve it from there. Just add 2 to both sides, then divide everything by 5, and that'll give you x. So you get 1.044. Now over here, the base is 10. So I can take the common log, so I can write that as the common log of 10 to the 1 minus c equals the common log of 20. And then I know if I take the common log of 10 to a power, that's just going to give me the power. And then so I have 1 minus c equals log of 20. And then if I subtract 1 from both sides, I get minus c equals log of 20 minus 1. And if I multiply everything by negative 1 here, that'll give me that c is positive 1 minus log of 20. And then put it in your calculator, and you get negative 0.301. Okay? So that's how you solve exponential equations. In the next video, I'll show you how to solve some log equations.